We are asked to solve the following equation: cosine of 2x equals cosine of x, and to give exact solutions which lie within the unit circle. So cosine of 2x is a double angle identity. Cosine of 2 theta is equal to 2 cosine squared theta minus 1. So let's rewrite this with theta. Cosine 2 theta equals cosine theta. So let theta equal x. And then let's substitute this over here. So 2 cosine squared theta minus 1 equals cosine theta. Now let's subtract this cosine theta over to this side. 2 cosine squared theta minus 1 minus cosine theta equals 0. So I'm going to rearrange the terms in this by putting the cosine theta in front of the negative 1. So 2 cosine squared theta minus cosine theta minus 1 equals 0. And this is a quadratic function in disguise. So if we let cosine theta equal x, we get 2x squared minus x minus 1 equaling 0. So we have to find two terms that add to equal negative 1 and multiply to equal negative 2. Those two terms are negative 1 or negative 2 and 1. So we rewrite this equation as 2x squared minus 2x plus 1x minus 1 equals 0. Factor by grouping. 2x times x minus 1 plus 1 times x minus 1 equals 0. And so our two factors are x minus 1 and 2x plus 1 equals 0. So setting both of these equal to 0 individually, x equals 1 and x equals negative 1/2. But remember, x is actually cosine theta. So rewriting this, cosine theta is equal to 1 and cosine theta is equal to negative 1/2. So looking at the unit circle, which angle value has a cosine value of 1? That angle is 0. And which angles have cosine values of negative 1/2? Those angles are 2 pi over 3 and 4 pi over 3. So the solution to this equation over here, the values that lie within the unit circle are 0, 2 pi over 3, and 4 pi over 3.